All right, this month we are going to talk about why I use Visual Studio and ReSharper for my day-to-day environment. So, Visual Studio you probably know about. ReSharper is a commercial product from JetBrains. It's an add-on for Visual Studio. It works in the Community Edition or the Professional Edition. All of them, all the different editions of Visual Studio support add-ons. And first, we're going to do a little bit of a slideshow. Okay, so little bit of story time. The very first editor I ever used was called Tico. This was a line-oriented editor for DEC machines. And commands were single characters. Sometimes they were control characters. It was Turing complete in that it had its own macro programming language. You could write little programs in Tico. It was great for interactive computing on printing terminals, so either a dot matrix or a teletype. And although this was not an official supported product by DEC, basically everybody had it. And I used it on a PDP 1170 running a time-sharing operating system called Ristus. And this is what I used from around like 79 to 82 when I was a teenager. And it was really good for editing, text files with markup to produce reports. As a runoff is a markup language. It's kind of similar to troff. In fact, the roff part of troff, or groff as you might use from GNU, is an homage to runoff. I was writing programs in Basic Plus, so you edit those source files, editing text data files or notes or whatever you had laying around as text. You could edit binary files too with Tico, although there wasn't much need to do that, but it was possible. Tico didn't care. It was just bytes in a buffer. And because you could use this macro language in Tico, it was very handy to use Tico to perform some kind of algorithmic transformation on a file instead of writing your own program to do it. We're writing your own program. You're just using Tico to write the program. After that, I got on Unix systems, and there's the line-oriented editor that comes with Unix. Yeah, I believe it's still around, but originally Unix from AT&T, it only shipped with ed, which was a line-oriented editor. It's a very simplistic editor. This editor, people made their own enhancements and expanded it, and so EX was originally an expanded edition of ed, expanded version of ed. And EX had a simplistic visual mode for letting you see on screen what you were editing, more WYSIWYG, less command line oriented, where you see things as lines and you issue commands to modify lines. And of course, this became extended further to become VI on BSD Unix. And even if you had a non-BSD Unix distribution, you pretty much found a way to get EX and VI on your system, because VI was a much more convenient way of editing files visually. Because it's screen-oriented, it's terminal agnostic. People were using terminals back then, connected over some kind of communication line to a central machine that was running Unix. And because VI didn't care what kind of terminal you had, it was very popular. And this is pretty much what I used in the 80s, writing C and Fortran programs. There was a companion program called CTags that let you build a database of symbols and references to your source files, and then you could use that to do a kind of primitive form of I type in the name of a symbol and take me to the place where that symbol is defined in my source code. And then after that, I started using Emacs. Emacs originally started as a set of Tico macros that gave you visual editing of files with a, which explains why Emacs is kind of obsessed with control characters as commands, because it comes from the Tico heritage. And at some point, Emacs gets rewritten as a native program with a Lisp dialect for extending the facilities of Emacs. Emacs has this concept of major and minor modes for editing source files. So using major minor modes, it can provide some things like syntax highlighting, and it can provide some limited forms of understanding the syntax of the files that you're editing. Emacs is what I used basically throughout the 90s. Around this time, there were these things called CASE programs, computer-aided software engineering. The idea was to, these CAD programs in the mechanical, electrical engineering domains had evolved into very elaborate suites of tools for mechanical design and electrical engineering design, circuit design. And they thought, hey, why can't we apply this same knowledge to software engineering? And although these were popular at the time in terms of the amount of press that they got in the trade magazines and whatnot, I don't know anyone that actually used them. Now, I think they were kind of, looking back on it in hindsight, I think they were inspired by the very productive environments that were around Lisp machines and Smalltalk machines. These were, you didn't really have an operating system. You just had a machine and you loaded a Lisp kernel into it, and you just, to do more things and get more features, you just loaded more and more Lisp into it. Same thing with a Smalltalk machine. In the early and mid 80s, people were making Lisp machines and Smalltalk machines, and they were very productive programming environments, but they were limited to these the one language. And because there was no real operating system, it was kind of, a way of writing software that was so orthogonal to the way everybody else was writing software, of like have an operating system and you ship a binary to customers, and they load the binary, install it onto their system, and then they run the binary. Lisp machine and a Smalltalk machine are very, very different. But I think that's where a lot of the inspiration for these case products came from, was reading papers and presentations about these Lisp machines and Smalltalk machines. Emacs is pretty much what I used all throughout the 90s, and C tags got enhanced into E tags. But still, although the editor itself was very extensible, we could write arbitrary amounts of complexity into it. Emacs itself never seemed to evolve past like just simple syntax highlighting and symbol navigation. I have a theory on why that is, but I think we'll kind of save that for later. But at a certain point, I started using Microsoft Visual C++ 6 in the late 90s, early 2000s. Now that's Windows only, and it's the first time I ever used a so-called integrated development environment. These case systems kind of presented themselves as an integrated development environment, but it was too much, kind of things that looked cool in a demo, but things that weren't really helpful to me as a day-to-day programmer. So that I don't know anybody that adopted them. They looked, fancy, but I don't know anybody that used one. They were available on SGI workstations that I was working on in the 90s, but nobody used them. We used Emacs. Now, when I switched over to working for a place that was doing Visual C++, initially I was using Emacs to edit code because, my muscle memory on all my fingers was trained for Emacs, and I was using Visual C++ 6 to do the building. And eventually I just learned how the key, what I wanted to do, what editing operations and navigation operations I wanted to do, how they were bound to Visual C++ 6. And so eventually I weaned myself off of Emacs. Now, an IDE is a little bit different than just a plain editor. It maintains the the idea of your project and your build, everything, your compiler settings, everything is all inside the IDE. So instead of hunting through some man page looking for the obscure compiler option that changes some particular setting, you have dialogues with GUI controls controlling those options, and presenting to you inline help explaining what the option does and what the different settings do. And there was also an integrated debugger. And up to that time, I had been using a kind of GDB, DBX kind of debugging experience. And the debugger in a GUI was new for me, and that was a serious upgrade over just plain command line oriented debugging, typing in commands to print the values of symbols and changing the values of symbols, changing memory, inspecting memory. There was also this concept in an IDE of wizards for generating boilerplate code. At the time, I was doing COM object development, so there's a lot of kind of scaffolding you need to use to create COM objects, which is basically boilerplate code. And the Visual C++ IDE, it wasn't yet Visual Studio, had a little sequence of dialogues that would take you through and ask you basic questions about the fill in the blanks for this template of code that it was going to generate. And I say template in the sense of kind of fill in the blanks as opposed to a C++ template class. And that was what I used for a few years before Visual Studio came out, where they unified all their different language products, which each one had its own IDE. They unified that into a single IDE. So you could have a project, or some, in Visual Studio parlance, it's a solution, and then projects are basically represent targets, targets in a makefile sense. So an executable or a shared library, a static library, or so on. In a Visual Studio solution, you could have one project be in C# and another project be in C++. Another project could be in COBOL or whatever other languages were supported by Visual Studio. And you can have all the different languages together in one place. I never really did much of that except when I worked on C#. There was a lot of all the new code was being written in C#, and our so-called legacy code, or code that had to deal with low-level APIs in the operating system, that was written in C++. So it was convenient to have those all together in one place. And since switching to pretty much, switching to Visual C++ 6, and then the rebranding as Visual Studio with multi-language support, that's pretty much the IDE that I've been using ever since. So that's 20 years of camping out in one piece of software. So there's got to be something in there that I really like. Now, Visual Studio has the ability to extend itself with add-ons. I think add-on is the official name. One thing about Microsoft is, for some reason, their internal corporate structure rewards people for constantly changing the names of things as a way to make a name for themselves in their career ladder. So, they used to be called extensions, then they were called add-ons, and then they were extensions again. But if I waffle around in some of my terminology a little bit, that's why, because I've been using this thing for so long, but they keep changing the names of things. But it's still the same item that we're talking about. And extensions, they can do little things, or they can provide large chunks of functionality. So, like, somebody might give you an extension that all it does is let you manage a library of copyright boilerplates and lets you insert them into the current file in the editor. Or it might go so far as to provide syntax highlighting for an entirely new language that's not supported by Microsoft's base product. For instance, COBOL, ALGOL, APL, what have you. Some kind of exotic program language, MATLAB, who knows. They can also do things like static code analysis. They can do implement exotic build systems. They can provide refactoring support for your source code. And sometime around 2007, extensions for C and C++ refactoring begin to appear. And I had gotten interested in refactoring because I had been working with a legacy 16-bit DOS application, and I wanted to modernize that application. And so I was trying out these different extensions in the late 2000s. Some of them were good, some of them were not so good. And I created a refactoring test suite, which you can find on GitHub, because some of these tools weren't really working as well as they could, or as I felt they should. And we'll look at how ReSharper does on that refactoring test suite. I didn't have a recorded date here for it, but at some point, Visual Studio itself began to get refactoring support for C++ and for C. I didn't write down what year that happened, but I also have in my test suite results, I have results for Visual Studio. And Visual Studio is not bad out of the box. So if you're just using Community Edition Visual Studio, you do get some decent basic refactoring support. But ReSharper is better. We'll show that. So ReSharper, it first comes out as an add-on for C# productivity in 2004. And I was using that while I was working at a company that was doing .NET development, and it was just awesome. It was great. I had never used at this point. I had never used their primary product that JetBrains became kind of well known for, which is a Java development IDE called IntelliJ. But I was using ReSharper, and that was great. And a lot of the ideas on ReSharper were coming from their experience in refactoring Java code with IntelliJ. And then around 2015, so about 10 years ago, they introduced ReSharper for C++, which a lot of times people just call R++. And they started providing refactoring support for C++ at the same quality level and feature scope as ReSharper for C#. And at this point, I can't imagine working in C++ without ReSharper for C++. I use its features every day, even if I'm not refactoring. We'll see what those features are in a little bit when we get to look at some code. But I literally use this thing, probably when I'm in the editor, I'm probably using it, a feature from it, every few minutes. So let's take a look at some code here. So this is the page for ReSharper, and here's my refactor test suite. These are relatively recent results. I haven't found a way to automate running the suite yet, so I kind of have to do these tests manually. But in this column, you can see the results for ReSharper for C++. I have, each row is a different refactoring, and you can see some refactorings can be applied by Clang tidy. CLion is a cross-platform C++ IDE that JetBrains makes. So you can use CLion, which is an IntelliJ-based IDE on Linux, and get a lot of the same, if not all the same features that I'm describing here today. Visual Assist X is another add-on for Visual Studio. It's been around for a while. And Visual Assist X is good for navigation, but it's not as good as even Visual Studio for a lot of refactoring tasks. You can kind of get an idea from rename here. Rename is probably the single biggest refactoring you're going to do on a day-to-day basis, because naming things is hard. This stuff changes over time. You realize this name stinks. Let's put a better name on it. Visual Studio coming in at 87% pass. ReSharper coming in at 99% pass. CLion coming in at 95% pass. And Visual Assist coming in at 67%. So, Visual Assist is okay, but and Visual Studio does decent, but ReSharper does the best. And because there's so many different identifiers that you could rename, everything from macros to template arguments to template classes to template functions to parameters to functions to members of a struct or members of a class, members of a union, concepts, macro argument names. I mean, just names are everywhere. And being able to change those and have it be changed consistently wherever it's used is a tall it's a tall order. These numbers here is 1,576 test cases were executed out of 1,576, and of those test cases, 99.05% passed as of the time that I ran this set of tests. Why would some of the test cases not run? Well, because the tool didn't support renaming whatever identifier it was I was trying to rename in that particular test case. You can drill into this repository and see all the test cases. They're all available as source code in this repository. I have little helper scripts that help me put these results together. But the high scores on all these different refactoring test cases that I've put together is why I use ReSharper for C++ on a daily basis. And if I had to work someplace where I couldn't use Windows and I couldn't use Visual Studio, I would go back to CLion because it's from the same people and the results are nearly as good. So that's the test suite. We'll look at that a little bit later. Okay, so let's go over here. Let's go to the other project first. This is an open source project I have on GitHub. This is that DOS program that I've been modernizing, as I was saying. And we're going to bring Windows into the view here as we go through things. Without a doubt, the single most common thing that I use all the time is I know the name of a file or I know the name of an identifier and I need to get that file open in the editor, and if it's an identifier I need to get to where that identifier is either declared or defined. And although there's many different ways that you can navigate to the definition of a symbol, some of which are supplied by Visual Studio itself, I'm almost always using the Control-T shortcut in ReSharper, which is basically I'm going to just start typing and you show me everything that's relevant. So I know there's a file in here called makebatchfile.cpp. You notice it's showing me here's the function declaration in the header. Here's the function definition in the source file. Here's the source file, which happens to be named after the function. Here's the header file. I just want to go over here to this source file. And if I want to go to the function, I can go down here. And now I'm at the function. And I've got a cyclomatic complexity extension installed here too. That's a free extension that's available on the Visual Studio Marketplace. So that's why this thing it's got a squiggly here. It's saying the complexity is too high. You know, this is old code. They tend to have long functions that go on and on and on and on. So that's why a lot of these, with loops and ifs and all kinds of things inside, like here's a doubly nested loop with ifs inside it with a while inside the if, so the cyclomatic complexity is high on this code. And that's why we need automated refactoring support, because manually changing this code is dangerous if we don't have tests around it. So if I can apply a source code transformation that improves the code a little bit, that's going to be preferable to doing a change manually, because if I do it manually, I may have to deal with compile errors. It's a big distraction. It's like too much of a pain in the butt, so you don't do it that often because you did it manually, you always have the chance that you might introduce a bug, and there's no automated tests around this code, so now you've introduced a bug, and now I got to go do manual testing just to validate that I didn't break it. That's a whole lot of trouble, right? We don't want to do that. Let's just let the sleeping dragon lay there and not disturb them. So if we have automated tools for improving our code, we're gonna take advantage of that and improve things little bit by bit as we go. And in this repository, that's, you know, I've been on that kind of a quest for a number of years, and I've made thousands and thousands and thousands of little commits that improve things bit by bit. And we're still making changes along that nature, but they're kind of, you know, the nice. We've finished off some of the nasty things, and now we're into the nice to have things. So Control T to navigate around is something I use all the time. Another thing that I use is find references. So if we go onto a symbol, now I'll show you. You can get there through context menus. We can go to Navigate, Show Usages. Show usages of, it happens to only be used in one place. So that's probably not, let's try this. It wasn't a good example because it didn't show a list. Let's look at this one. So down here we have a function called input field. If we go down here to, I usually do this straight from the keystroke, Shift Alt F12. I normally don't do this through the context menu, but I'm showing you the context menu so you can kind of see how to some of the functionality that's provided. This context menu is populated with some things from Visual Studio, some things from ReSharper. This show usages, it's also a function in the core Visual Studio, and when ReSharper provides a better version of the same functionality, they kind of steal the shortcut, and the keyboard shortcut goes to the ReSharper implementation. So if I say show usages of input, oh, I see what it was doing. Let's try it this way. If I Shift F12, it's not quite bound to the context menu as I have it bound to the keystroke. Whoops. Find results. Pinned. But we want it over here. Here we go. Okay, so this find results, this is the find results coming from ReSharper, and it's showing me here's where the thing is defined. Up here, that's the search target, and then I've got the results organized by project, then by type, and then by member. So here it's showing me there's a library called libid, and then inside there it's referenced from these two files. And then from this file, it's referenced, here's the function that is calling the search target, and then here's the call site for the search target. This full screen prompt, sorry, double-clicked one thing here. If I search for this thing, now I get this full screen prompt. This is originally a DOS program, so the user interface is kind of text screen oriented, and this full screen prompt is a thing that basically builds a text screen with a bunch of input fields and labels and handles all that logic. And you can see I've got these different get whatever CPP files. These are basically dialogues. You can think of them as one for getting 3D parameters, one for getting a fractal type, one for getting a random dot stereogram parameters, one for getting one screen full of options, a second screen full of options. They call them toggles. For view parameters, for options specific to passes as we traverse over pixels on the screen. How are we going to compute the fractal at those pixels? And although this is kind of a small project, you can get the exact same amount of knowledge on a large project. A really good example of trying it out is to clone the LLVM repository that will give you the source code for Clang and all the additional Clang tools and the LLVM intermediate representation and all those tools that go around code generation from that intermediate representation, the code that takes input languages via a parser and creates the intermediate representation. There's a lot of code in a compiler, and I believe like Clang has something like 600-700 different targets that get loaded into Visual Studio when you generate a Visual Studio solution with CMake. And try that out with ReSharper. We'll see what that looks like in a little bit. Now, find references. This is something I use all the time. Like, I can't think of a day when I've been developing, in the past few years where I didn't use find references, because that happens all the time. Chances are the code base you're working on, you didn't write every single thing that's in it. So you're changing something, you want to know, well, where is this thing called from? You're going to have multiple items that you're going to be looking for usages of. And you'll notice here, every time I did an invocation of find usages, it created a new little tab inside here. And if I'm changing my source code as I go along, and now I've changed the usage pattern, I can go over here and refresh it, and it'll run the search again. So here, in this case, it's probably a bad name because it's a function that begins with M. Let's see if I go to choice builder, which is a template class, and choice builder, it has member variables in it. If I just F12, it'll take me to the definition of that identifier. We can see that it's a member inside here. And if I shift F12 on it, I'll get all the usages of that member. It's a private member, so these are all methods within my choice builder template class. So F12, if I'm on a symbol, F12 will take me to its definition. If I am, let's just go over here. So here's a usage of this function full screen prompt. If I F12 on it, it takes me to the definition. If I control F12, it takes me to the declaration. Because sometimes I want to go and see the header, sometimes I want to go and see the implementation. So I notice I don't have to navigate over here to Solution Explorer and click through a bunch of things to find the header file. I don't even need to know what file the thing is declared in. In my case, I've got a lot of files named after the main thing that they're declaring, so the file is actually called fullscreenprompt.h. But, your source code is going to be different. Yes, I can drill through these folders in my, we're at full screen prompt. I can drill through here and get that file open in the editor, or I can get to it with Control T if I know the name of the file I want to get to. But a lot of times I'm just drilling through usages and it's like, oh, what's the name of that? How's that thing declared? Maybe there'll be some function documentation here. There's not much documentation in this code base. Maybe it has some doxygen on the function declaration that is going to explain to you the meaning of the parameters to that function. Usually the doxygen will be on the declaration and not on the definition. Other times you want to know, what's going on in the definition. How is this command line parameter, how is that being used? I can shift F12 on the command line parameter, and now I'm getting a list of places where all this little values parameter, how it's used inside this function. Another thing that's very useful is I know the name of a variable. Say this variable scroll file here. It's being used a bunch of times inside this function. I did a shift F12 to get usages shown to me. But what I'm really interested in is when somebody does a modification of that value. So I can show only write usages to that variable. Now here it's showing me I passed the address of this variable to some other function. So potentially that function could modify that argument through its address. So that's why those instances are showing. And then down here where the variable is assigned to null pointer, it happens to be a file star from standard IO. When it's assigned null pointer, that's another write usage. Or maybe I'm only interested in read usages and I don't care about write usages. I can filter that up here. I can further type things in the search bar to narrow the results to things that contain the text that I've typed in here. Now in this code base we're looking at, it's a small, it's a small number of results, 16. But if we're looking at a code base like LLVM or Clang, it's going to potentially be tens of thousands of references, right? So even just narrowing it down to a write or read might not be good enough. So the search bar is very useful for filtering things down. And I'm not going to describe every single little feature of ReSharper here. I'm just going to tell you about the things that I do on a day-to-day basis. The next most common thing that I will do with ReSharper is some sort of refactoring. And I'm not going to walk through like an elaborate example here, but I do have one example where I made a little tag in this repository to show you an example. And I'm going to go back over to make batch file. Oops, I got ahead of it because I changed the files underneath it. So, okay, Control T. Make batch file. Go look over here. Now, this expression, let's just get that out of the way for a moment. This expression here, it happens to be that it appears 3 places inside this function. So here's the first one. And these, in this code base, anything starting with a G underscore is a global variable, of which you'll notice there are many. That's one of the reasons why this code needs to be incrementally improved over time, is because there's a lot of communication of information out of, kind of out of band, if it were, through global variables. It's connecting things together, and that has side effects. It also makes it pretty much impossible to take this code and run it multi-threaded, which would be an obvious speed up for a fractal renderer, but I can't quite do that yet because everything's communicating through global variables, which is going to mean, nasty multi-threaded bugs to figure out. Okay, so suppose I want to take this expression, and I know it's repeated, and I don't want the repetition because duplication is a source of errors. So let's extract it into a variable. I'm going to do Control RV. I'm going to extract it into a variable, and ReSharper says, hey, inside this function, you're using it in 3 places. Do you want to replace all 3 occurrences with a new variable, or just the one? Well, great. I want to get rid of the duplication, so let's replace all 3. It figures out that the type of the extracted expression is a bool, and it's asking me, do I want to use a bool or do I want to use some other type? Well, yeah, I do want to use a bool. It doesn't know what name to give this thing. It suggests cond for, euphemistic suggestion for a condition. But let's, let's see if we can come up with, a good name for this. Has color table or something. And now, this new variable, if I show usages, you can see the 3 places where it replaced it was in that it was a repeated expression inside 3 different if statements. So that sort of thing is extremely useful. And the ability of ReSharper to say, hey, that thing that you wanted to pull out, I saw that it was duplicated elsewhere within the scope of this code. Do you want me to handle all the duplications or just the one? Sometimes it's just the one. You don't necessarily want to have it always do one or the other, which is good that it prompts you. But it's kind of a nice added bonus that was like, hey, we got rid of that duplication here, and you'll also notice that there's this little hammer that shows up over here. These are context actions that can be applied to wherever you are on wherever your cursor is in the editor. In this case, it's offering, we can split declaration and assignment, and in which case now I have the declaration separated from the assignment. I can go move the declaration up here if that's what my coding standard says to do, or maybe maybe there's some other reason why I want that declaration placed somewhere else. I can also, let's see, if I go over here, and then on this symbol I say inspect, and I say inspect this, I can inspect code issues. Bring that over here. And this is basically performing a restricted static analysis, and it's done the analysis on this file. If I were in the scope of a class, it might do just the analysis on a class, but it'll run Clang and Clang tidy checks. So Clang has basic static analysis diagnostics that it can issue, and I'm looking for it's done an analysis on the whole file. I thought it was going to suggest that I could make this thing const. I mean, because I can make this const. It's not being changed in this function. It could be that I've changed the the default suggestion for things. But the point is, with inspect this, you can run static analysis checks on an individual file, on an individual project, or on your entire solution. And Control-Alt-V will bring this window up. We can pin that so we can see what kind of things are going on in there. I've been using this to fix, things that thinks are spelling errors. A lot of times it's basically, it considers a spelling error something that it recognizes as a word, but doesn't appear in its dictionary. So you might think, well, that's great, but I've got all these terms that come from my problem domain, and I don't want them all getting flagged as spelling errors just because they don't appear in some kind of standard dictionary. But we can go and to options for ReSharper, and if we go to spelling, this is one thing I really like about there's a lot of options, but you can type text in here and it will show you only those options that are relevant to ones that contain that text. And we can go over here. Here's a list of exceptions, that I've put into ReSharper over time, so you can customize that. And they actually have there's a lot of settings in that dialog. Some of those settings are going to be to your personal taste. Some of them are going to be to the preferences of your team's style guide or what have you, and some of them are going to be specific to a particular project. And they have what they call a layered settings mechanism that allows you to specify settings per team, per computer, per project, per user, and the layered mechanism is how they all get combined together to result in a final set of settings that are applied when you open up code. So that's one of the first things that happens is you start using some of these tools and they get customized with settings. It's like, all right, well, how do I share these settings with my team? How do I've got one set of settings in this project, and another set of settings in this other project. They have, for whatever reasons, they have different histories, they have different coding styles. I don't want to uniformly just kind of smash everything with one big hammer. I want to be adaptive based on the project that I'm in. So that's a nice thing that they've done with their settings mechanism. So let me go back over here and restore this and go back to the head of the branch where this code has since been refactored, into a class with methods. This code's very different now. But as I said, the most common thing you're going to be doing refactoring wise is rename. So I believe it's the default keystroke, but I've got it bound to Control RR to rename whatever identifier my cursor is on. And in this case, it's the local variable, and you can see it's highlighting all the uses of that variable within this scope. If I escape, it will cancel that out. So it's like, oh, that wasn't the thing I wanted to rename. I wanted to rename this thing. Suppose I want to call this thing read integer. It'll go out. This happens to be that template class we were looking at. So it renamed it, but you'll notice it opened up my unit test for that class. It opened up other source files that are consuming that class. Here's the header file where that template class is defined. And there's a couple other files we had open but didn't use that. So all the ones with the star here, these are all the ones that ReSharper modified. If I save that out, let me go back over here, take a look at what changed. We can see that, again, the header file, the tests, and the consumers of that method, all the places where that method was used, they all got updated. If we F12 on this method to go to the implementation, we see here it's been renamed. This is because it's a template class, the declaration and the definition are in the same place. If we do find usages on that, we see that over here in the test, it was updated in the test. And one sticky thing with these unit test frameworks is they tend to use a lot of macros. And so sometimes, like suppose we want to change this variable result, say we'll just call it foo for now. We got the identifier renamed even when it was used as the argument to a macro. And that's really important when your code base has unit tests in it, especially if they're G-test style unit tests like they are here, because G-test uses just macros all over the place. And so having a tool that can't rename arguments that are used, or can't rename symbols that are used as the arguments to a macro, that's going to be a serious impediment on making the changes you want to make in an automated and safe fashion. And the safety comes from the automated nature of the change and the confidence we have in that operation, because we can go and consult that refactoring test suite to see how good it is at that kind of operation. And we see that just ReSharper just is the best one at rename. There's a few things it can't rename yet. It can't rename labels that are the target of a go-to. But hopefully you don't have many go-tos in your code, so that's not a big problem in the first place. But rename I use all the time. So we'll save those changes, go back over here to Git, and we'll just undo them, just so we're back to the main thing. I showed you extract variable. There's also, sometimes the thing that you are extracting is just a magic number. And so if we go over here, let's go context on that, refactor, introduce variable, introduce field, depending on, let's see what happens if we go over here to this one. Refactor, introduce variable. I mean, I can always type const int here or const expr int. I'm inside the scope of this lambda. It wants me to confirm the new name. It's not so bad. I could make it a constant if I want. But sometimes you want to extract a constant directly. Sometimes ReSharper is smart enough to recognize that the thing you're extracting wants to be a constant, and it will ask you the choice between extracting it as a variable or extracting it as a constant. You can always turn a variable into a constant manually after you've extracted it. Let's just go back here. Let's get this extracted. We'll reformat this so it's a little bit nicer for us to look at. So I've extracted this thing, and then later I realized, oh, you know what? I extracted that, but it really didn't. It was only used in this one place, and the name, in place of this expression, that wasn't really the best thing. So I can also go over here, refactor, and I can say inline, and that does the opposite of extract. And sometimes when you extract things, you get a little ways into it and you realize, wait a minute, I actually kind of sliced this up the wrong way. And what I need to do is I need to inline what I extracted and then extract it differently. Now sometimes if it's just the same editor session, you can just do undo. But maybe, you did the extraction last week and this week you realize, oh, I kind of carved that up the wrong way. I need to inline these things back to where they were and extract it differently. So inline, being the opposite of extract, can be just as useful as, like I said, it can be just as useful. Inline can be just as useful as extract because sometimes you need to slice things up a little differently. Now, the other main thing that I do besides extract is what's called change signature. And if we go on to a function and we say refactor change signature, I normally do these things from the keystrokes. I'm showing you how to get there off the context menu, so because you can't see me typing. Now, what's interesting is from change signature, we can change the return type of this function. We can change the types of the arguments. We can change the names of the arguments. We can add or remove arguments. We can change the order of arguments. So this guy, I can move it up. And if I do that, notice it changed. If we undo, we see what it was. First it was the string literal and then the number. If I redo it, now it's the number and the string literal. And if we go to all the usages of this function, let's Shift F12, and I need to get it visible. Find results. Let's pin that. Okay, so usages of read integer. Notice down here, this one got crossed off because the code has changed. So if we, oh, did I do it something goofy, or did it mess up? Oh, it's not that. That's the wrong one. It's int number. Why are we not getting navigate, show usages? Well, that's Visual Studio doing that. I think it got a little bit confused because it's a template class. Let's save and try this again. Shift F12. It got confused. This is one of the reasons why, let's try this. Let's go back here. This is one of the reasons why I created this test suite, because no tool is perfect. Let's just restore this back. Okay. And we'll go over here. And instead of let's try make batch file. This only, oh my. Oh, I know what happened. Ha. Shift F12. Okay. I know what happened. On my keyboard, next to my F12 key is a function lock key, and occasionally I erroneously press that, and then it disables all the functioning of the function keys. And I have to check the little LEDs on my keyboard to make sure that that's not enabled. Okay. Let's try this again. Okay, so we go back here. Let's change signature on this. Change signature, Control RS, and we will move that up, apply the changes, and now I'll shift F12, and there's the usages. Here we have some usages in tests and usages in code, and if we go look at any one of them, we see that now in all of them the text string is second and the number value is first. Right, these all got switched. If I Control Z, now they're all swapped back. So change signature is an extremely handy refactoring because it lets you change the types and it lets you change the names at the same time. Like suppose I want to change this from a pointer to a constant character to a stood string. I can call this stood string. Maybe I want to take that as a const stood string reference. Go ahead and do that. And now that's been changed all over the place throughout. If we go to the definition, we see that this has been replaced with a reference to a stood string. This is a little bit goofy because it hasn't quite flagged it as an error yet because this is a template code, but really this would, to adjust this because I changed the type of the argument, this would need to be a C-stir now because this is a stood array of const char stars. You can't assign a stood string to a const char star directly. But because it's a template class, it wasn't able to flag it as a build error yet. So let's undo that. Put that back to the way it was. And we'll just validate we don't have any changes over here, right? Everything is good. But a common thing that I find myself doing when working on legacy code or working on code that needs to be, maybe it needs a new feature, whatever, and now the context in which these function calls are being made has gotten more complicated. Maybe I need to pass extra data through functions, or I need to take local data, I need to extract it and turn it into a new argument because it now represents something that is changing and not thing that's fixed. Change signature with add parameter is the thing I find myself wanting to do a lot. So if I add a parameter, suppose I need a float here and, I don't know, width or whatever it is. Now, because I'm adding a parameter, ReSharper doesn't know what should go into the call sites of that function for that new parameter. And I have the choice of leave it busted, and I'll just fix it myself by compiling the code and then dealing with the error messages one by one. I can use some constant. ReSharper will always suggest basically the equivalent of 0. So if it's a pointer, it'll suggest null pointer. If it's some kind of integral type, it'll suggest 0. Or if I know the context in which all the function calls are made has an identifier or some expression that is the right thing to plonk in, I can put that in here. So I can just say, well, let's just use this identifier width in all the call sites. If I then do Shift F12 to get all the references, I can walk through these usage results one at a time by pressing F8 when this pane is highlighted. You can also use these little arrows, the little down arrow, so I can press the down arrow, it'll take me to the usage, and you notice it put the identifier width there in the call site, and now in this call site that identifier didn't happen to be defined, so this is something I have to fix. But a lot of times if I'm extracting methods inside of a class, I'm taking a bunch of statements inside an existing method and I'm extracting it, I know the context that will let me supply in an expression or an identifier, and that will just magically happen to be the right thing to do in that context. So again, I'm going to save this and revert. Just an easy way to get those changes undone. I could have used undo. This business of, F8 stepping you through all the things in a pane, I don't know if you knew that, but if I look for just int number in the source code here for this project, and I just take, this is just the output of find in files, right? Standard Visual Studio stuff. Maybe you didn't know that in this list view only, there's a fancier view that they've introduced, but I prefer the classic list view. If you double click or press return on one of these lines, it takes you it opens up the file in the editor and takes you to that line. So you can double click each one of these, but also you can just F8 your way through them all. That's a nice way, if you don't have a good find usages, or you just want to grep for a certain piece of text and just want to step your way through it, F8's a good way to go. Let's go back here to the find results. And find usages is great, but it's not smart enough to peek through preprocessor conditionally compiled code. So it's if you have code that's disabled by a preprocessor block, find in files will find it, but find usages can't find it, because from the point of view of the compiler, that conditionally disabled code is dead. It doesn't exist. It doesn't appear as text to the compiler. It's completely stripped out by the preprocessor. So that's just a bit of fair warning. If you have code with a lot of preprocessor blocks, be careful with rename or find usages and whatnot. Rename can't see into those disabled preprocessor blocks, so when you rename an identifier, you might not find out that you missed one until you submit it to your continuous integration system and your Linux build breaks or what have you. That's if you're lucky. If you're lucky, your continuous integration system will catch it. If you're unlucky, it represents some variation of the code that people haven't built in a long time. And then next year, somebody says, oh, I need to build that variation, and they go turn that code on, and then it's all fails to compile. My recommendation is, if you have such variants of your code that are controlling conditional preprocessor symbols, you should have continuous integration jobs that run, maybe once a week, something, to catch those mistakes. Build all the variants on some cadence so that you don't go too long without having at least tried to build it and make sure that the code is compilable in all the different flavors. Ideally, just don't have conditionally compiled chunks. Sometimes it's unavoidable, but there are different ways to skin that cat. Okay, so change signature, very, very useful when restructuring code, especially when you need to inject new context by adding parameters. Sometimes you find out, parameters aren't being used anymore, and you can use change signature to drop those parameters. ReSharper is smart enough. Let's just write a function here that takes an int, return 0. ReSharper is smart enough to recognize, hey, you've got this argument declared. Let's go down here, write another function. ReSharper is smart enough to see you've got an argument here to this function that is not being used. So, by the way, this little light bulb thing, you can either click on it, or we can press Alt-Enter to get that to appear. What I end up doing is when I'm in the editor, I try to do as much from the keyboard as possible so I don't go to the mouse. Going to the mouse represents an interruption and a delay. I try to stay on the keyboard as much as possible. So learning these keyboard shortcuts to bring everything up is going to be to your advantage. This remove unused parameter, if I do that, okay, it dropped the parameter. It also adjusted all the call sites to drop out whatever actual value is being passed in. Because it didn't matter what bar was calling foo with, because it has no effect on the execution of foo. Foo did not use that argument at all, so it was just noise at the call site. It was distracting you from what was actually happening. You thought this foo of 1 was different from a foo of 0, but in fact they're always the same. So being able to invoke these kind of quick context actions with Alt-Enter is very useful. Now, here's one. It happens to notice, hey, this function foo, it's not called from outside this file. So there's a Clang tidy check called misuse internal linkage. And Clang Tidy support is integrated into ReSharper. It runs Clang Tidy on your code, and then whenever Clang Tidy suggests you might want to improve your code by, done an analysis for the check, you can apply that directly. So I can do it for this one instance, and it's telling me insert static to make that function's not visible outside this file, because nobody outside this file is calling that function. Also on that, these Clang Tidy suggestions, you can expand the scope in which you want to run that check. You can, and this happens to be a Clang Tidy check that can fix the thing that it is telling you about. In this case, inserting the word static. But you can say, like, hey, that's a good idea. Let's do it on everything in this file, or everything in this folder, or everything in this project. And again, in a Visual Studio parlance, a project is a target, so library or an executable. Or you could do it everywhere. Another useful thing that's handy to know down here is maybe this is a check you just think it's stupid. You don't want to do that at all. So you can disable it once, you can disable it in the file, you can disable it globally. When you do these disable things, it puts a little lint comment in there. But maybe you just like, what, this thing is too noisy, I don't want to see this at all. So you can go over here and change the severity of this particular context action. In this case, it happens to be a Clang Tidy check, but it could be any kind of analysis that's done on your code that suggests something. You can be like, just don't ever show that to me again, or show it as a hint, or make it an error. You can change the severity, and that's a really nice way from within the context of this thing being presented to you to be able to say, this tool, it keeps nagging me about this particular type of problem, but I disagree with the conclusion, so I just want to tell it to shut up. So you can do that. And as I said, those layers of preferences let you customize that across your team to the individual personal taste per project, what have you. There's also a way that you can take those settings, commit them to a version control system, Git repository, whatever, and that way, other collaborators outside your organization on an open source project, they can get those same settings. So we talked about navigation, we talked about some of these inspections, we've talked about navigation. We haven't talked about testing yet, because there's another thing that I use here inside ReSharper all the time that is very handy. So I am doing Control-Alt-L to get the context over to Solution Explorer, just so we can squish that down. Look at my tests. I have two, not test data, source files. I have two test projects in here. And this is legacy code. It doesn't have very many tests. When I try, when I modify the code, I try to see if there's a way to write a test first to cover the existing behavior. Like if I'm looking at some small function and I'm like, oh, there's actually a bug in this function that doesn't do something right, I'll try to cover the existing behavior with a test first before I change any of the code, and then I'll write a test for the bug that I saw when I was just browsing the code. And then I will modify the code to make the test pass. And then if I'm going to do any refactoring after I've got the functionality correct, I'll do that at that time. So there happens to be some code in here, this test comments guy. Let's pull that down. So I'm using Google Test, and I've got a test fixture here. So this test F is their macro for the first argument is the name of the fixture, and the second argument is the name of the test case. And the fixture just is a way to extract out duplicated setup and tear down noise that's going to be the same from test to test. And in this case, the thing I'm testing is this function called expand command comment. And again, this code riddled with global variables. So the input, the main input to the function that is being is the comment that's being expanded happens through these global variables here. And I'm going to call the function and get the result, and then I'm going to validate what happens. Now, you might have noticed these little balls appearing over here off to the left in the gutter, and they are colored in such a way that says, we don't know if this test is passing or failing yet because we haven't run it. I can click on that, and I can run that individual test. It's going to go ahead and, oh, I didn't build this code, so it's going to go build it. Let's get the test session viewer over here. Normally, I have some of these windows off on my second monitor. Like my build output right now is off on the second monitor. So if you want to see that, I can bring it over. Okay, so we're building some code. Here's the main library containing all my production code is getting built. I updated the code from the repository on GitHub on my local machine before this talk, but I didn't build it, so it's not going to take too long, but it's going to go and build all this stuff first. All right, now we're building the test code. And we're linking the test. Oh, I have some junk from work I need to clear out here. Unit testing, test frameworks, C++. I need to clear this junk out. It's overriding. It was overriding its idea of which executable it should run. Let's try that again. You go over here, and we'll say run this test. Now everything's built, so it should just run it. And we can see, okay, that was a successful test. If I go and change this thing, put some junk in there on the expected results, and I run this again, it's rebuilding whatever's necessary, running it, and it says, oh, now here's my Google test assertion failure. I expected this string to equal this string. Oh, I expected this string to equal the value of this expression, which is this second string, and they didn't match. So I can go over here. We'll just undo that, and then I can run this individual test from here, or I can go over here and say, you know what? I just changed something, so let's go make sure that all these tests relating to this test comments fixture, let's make sure that they all run. So we rebuild our test code, reran all the tests, and they're all green. And if I double-click any of these test case names, it takes me to the definition of the test case inside my source code. Now, that's all cool. That's just kind of, you know, fancy GUI around running my tests and visualizing the results, and that's all great. But a lot of times what happens is some test is busted. We're not exactly sure what's going on. We need to run the test in the debugger. So normally you would put, you know, a breakpoint on the debugger, and then you would come over here to your test executable, and you would say, make this the startup project, and then you come, then you come into here, and you say, go to the properties, and go to debugging, and then set, you know, gtest filter equals blah, 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 blah. That's a lot of stuff to go through, but I can debug the test straight from either here by clicking this debug icon, or I can go over to the little bubble and I can say debug. And ReSharper is smart enough to know, oh, you're using Google Test. I know which test executable is associated with this test case. I know the test case name, so I know how to tell Google Test, here's the appropriate filter to run just this one test only. And now I'm sitting at my breakpoint, which is about to execute my production code. I can start stepping into this code, finding out what's going on, and going through a few function calls, and then here's this main loop where it's interpreting some kind of string to figure out what it's going to expand it to. I can step out, and then I'm back into here. I can, let's bring this over. I can look at variables, of course, in the debugger. You know, it's just a normal debugging session. I've got access to everything, but it's from within the context of, oh, now I did it. Messed up all my windows. Well, I'll deal with that later. Okay, so let's just get back to what we want to get back to. So the point is, it can be very handy for debugging your test cases because I aborted the debugger. It's saying the result of that test execution was aborted. I could run it again just to see it go green. I didn't change any code, so it's back to green. And then within this test runner, you see here, it's like it knows that the name of the target that contains the unit test is called test-id. I can add all the unit tests that are inside that test executable, and again, I can narrow them down by typing in the filter box here. So I type COMM, so some of these have comment in the name of the test, some of them have command, so on. So a lot of ways you can slice and dice your tests. And this ability to run a specific test or debug a specific test from the little bubble or from inside the test runner here, that is something I do all the time when I am writing or debugging failed tests. We talked about context actions, but let's just talk a few things a little more. Let's give this an argument. Oops. Okay, so this kind of a thing shows up in your code a lot. Now, it got squiggled under it because there's a Clang tidy check I wrote called simplify Boolean expression that recognizes this kind of, if condition return true, else return false. It recognizes that you can just simplify that to just return condition. But from inside ReSharper, we can convert an if statement to a ternary expression. And we can do the reverse. We can convert the ternary expression back to an if statement. And ReSharper is smart enough to know this else statement is redundant, so can remove the redundant else, and now we're back to what we started with. But the ability to switch from ternary to if and if to ternary is extremely handy. I do that a lot, 'cause sometimes it's a judgment call, right? Is this better read? Is this better read as a ternary? Now, again, the true-false business got dimmed out because it said, hey, that thing can still be simplified. The Clang tidy remove redundant conditional expression is still in effect. You notice here, remove redundant conditional expression. That's coming from ReSharper, and then this one is the readability simplify Boolean expression check from Clang tidy. So sometimes ReSharper has overlapping functionality. Whenever it's suggesting a Clang tidy fix-it, the name of the fix-it would always be in the square bracket here. And when you expand this out, it's obvious that it's Clang tidy. Whereas this one doesn't say Clang tidy because that's coming from ReSharper. I found that these kinds of transformations, I happen to be the author of the Clang tidy one, so I know that one is robust to my standards, because why would I write code that didn't meet my own standards? But also these relatively simple conditional transformations from ReSharper, they're very robust, and I've never seen them. I rarely ever see them go wrong. And speaking of which, things that can go wrong. No tool is perfect, as we saw from the. I do have LLVM up here in another instance of Visual Studio, but it's just more of the same. If you want to try out ReSharper on a very large code base, I would recommend cloning LLVM and Clang Tools Extra. Get all that Clang goodness in a local repository, configure it with CMake, open it up with Visual Studio, and use the 30-day free trial of ReSharper and give it a go. But like I said, no tool's perfect, and you will, as we saw from the test suite. Let's go back and look at the test suite real quick. No tool's perfect. There's some of these where ReSharper's 91%, or didn't offer the functionality, so it was 0% on that particular transformation, or it just did okay, only 50% passing. But most of the scores are high. But it's not perfect. No tool is perfect. So one obvious follow-on question is, if you report a problem, what do they do about it? Now, I've been running this refactoring test suite for a good 10 years, and I've been using ReSharper for C++ for 10 years, and before that I was using ReSharper for a few more years before that. And I've filed a bunch of different bugs against ReSharper for C++. And my experience has been that JetBrains is very responsive. Sometimes, the bug gets fixed within a few days, or sometimes it's a few weeks, or sometimes it's, slated for a subsequent release, or sometimes my bug is still open. It depends on, the difficulty of what it is I'm asking them to do. My experience is generally that, small bugs, little mistakes get fixed quickly. For instance, it's not a deal breaker, but sometimes you do a refactoring operation and it results in code being, let's go back to here, results in code being inserted. The refactoring might need to insert like a pound include of the algorithm header or something like that. And recently I filed a bug that said, hey, my line endings are carriage return line feed, and when these extra lines got inserted, they had line feed line endings. It didn't match the line ending convention of my file. So when I go to add the file to Git says, oh, by the way, you have inconsistent line endings, and the next time you check out the file, we're going to make them all curly lifts or whatever your Git convention is. And, it didn't take them long to fix that. Other times, it's a more, a deeper request. C++ has the idea of like static polymorphism with template classes, and sometimes you have a group of template classes that they all implement the same static polymorphic interface. And ideally, you'd like to be able to rename the method on one of those classes and have all the other ones get updated. But that's a big ask, because you're asking ReSharper to go through all the template instantiations in your project of that template class and then identify which one of them are using that method call, and then make sure that they all get updated, in a corresponding way. Not only all the definitions in all the related template classes that share the same idea of a static interface, but you have to rename all the call sites as well. So that's a tall order. And I'm not afraid to ask the guys at JetBrains a tall order in a feature request, but I'm also not surprised if they say, it's going to be a while, if ever, before we get to that. I think concepts are getting to the point where, where you say a template argument has to model a particular defined concept. They do pretty well on renaming things in that scenario. If we go over here and look at the test suite, we have rename CPP20, and I think I have a concept in here. Rename CPP20 concepts. So these are test cases that I need to write around concepts. I haven't written them yet, but there's the related idea of constraints to template arguments, and you can see I have a bunch of different test cases in there for that, and they are doing well on that. So no tool's perfect. What happens if you file a bug? How are they going to treat you? In my experience of using their stuff for 10 years, they treat customers very well with respect to the bugs that they submit. Many times I'll submit a bug that I encounter on something, and it's already a duplicate of a bug that some other customer has submitted, and it'll get fixed when the original person who requested or reported the problem gets fixed. Now, I'm sad to say that this is a stark contrast to the way that Visual Studio handles bug reports against their product. When I went recently and updated the refactoring test suite, because I added all these test cases for C++ 14, C++ 17, C++ 20, and there's still more 20 syntax situations where identifiers are introduced to that renamed test cases could be added. We saw that. I just had a stub out there for the concepts. But I had reported bugs against Visual Studio for a bunch of these failing test cases, and they're just very poor at communicating to reporters of bugs what's going on with the bug. And sometimes the issue got fixed, but I never got notified. Most of the time, they just seem to be in a rush to close my bugs without doing the minimal amount of thing that they can possibly do to close my bug. Like if I don't hold their hand every single day for 3 weeks or whatever, they're just going to close my bug from inactivity or something. And I just don't think that's a realistic way to treat your customers. I'm not a beta tester for Visual Studio. I'm a customer that uses Visual Studio to get my own stuff done. And if I take the time to report a bug, and then 2 weeks later you're just like, well, you didn't respond to our little chit-chatty questions, so we're just going to close your bug after 2 weeks. It may be a month or 2 months before I can come back and respond to whatever it is you're asking for. I'm not camping out on your bug database waiting for you to ask me something so that I can respond immediately. I don't think that's a good way of dealing with customers. And my experience with JetBrains has been complete polar opposite. They may ask me for something. I may come back, some cases I've had this refactoring test suite for 10 years. In some cases I've filed bugs years ago, and they might have asked me something, and I come back and answer it like a year or two later. If it's that much time has gone, I try it again to see if it's still a problem. Obviously, they may have fixed it in the meantime. But if it still happens, I'll supply the extra information thereafter. They're not in a rush to close my bugs. So who cares if there's open bugs? We're trying to have a conversation to resolve problems. We're not gaming the metric of a number of open bugs as an important thing and trying to close as many open bugs as possible. That's not the goal here. The goal here is, with a bug database, is to fix problems and address issues, not just be like, oh, well, you didn't talk to us in 2 weeks, so we're just going to close that bug. So enough kind of whining aside. My experience with JetBrains has been extremely positive on the bugs that I report to them. Now, a lot of the bugs are that I encounter, they happen to be me working on open source projects, so it's very easy for me to say, clone this repo from Git, check out this hash at this particular revision, configure it with CMake, go to this particular source file in this particular line, and do this particular thing with ReSharper. And this is what happened, and I expected something different. So it's very easy to reproduce the bug because I'm working on this open source stuff. Of course, the same was true when I was reporting bugs to Visual Studio. It's just a difference in attitude of what we're going to do with those bug reports. And like I said, sometimes I report a bug, it's a feature request, and it's been open for 10 years because I'm asking them to do something really hard with respect to static polymorphism, or some kind of, use case where it requires global analysis of all the source code and your solution in order to come to some kind of meaningful conclusion. Those are tough problems. So the fact that it's still open, sometimes you come back a couple years later and you're like, oh, I just had an idea about how maybe you could tackle that thing I was asking them for, and I go and add it in onto the bug, and then maybe the developer or one of their people comes back with a, like, yeah, it'd be great if what you were suggesting is actually possible, but you can't do it for this, or the other reason having to do with, C++ being notoriously difficult to parse and notoriously difficult to reason about and so on. But, they try their best, and that's all I could ever ask from somebody. I should mention, I pay for ReSharper. I don't get a free copy. They don't pay me to say any of this stuff. I'm just simply an extremely satisfied customer, and I use this stuff every single day. We didn't talk about a lot of the inspection stuff. Control-Alt-V will bring up the inspections window. My code base has, for this fractal renderer, it comes from DOSland, and it had many different contributors, all of which had their own, personal style. So the names of the identifiers were not consistent throughout. I recently made a big pass through this code and tried to get all the identifiers to be consistent. Having this inspection down here, the spelling issues, it generally is considered a typo in the identifier. That was extremely useful for me to be, you can see I still got 1,173 items in here. That, either most of those is because I haven't shared the dictionary of the false positives, words that are coming from the problem domain of this code base. But being able to go through there and find all the identifiers that weren't following an identifier convention, which, by the way, if we go over here to options, and then I think it's naming. Okay, inconsistent naming is the check. Sorry, that's for C#. Inconsistent naming is the check that checks the names of identifiers against your naming convention. And I think maybe down here, naming style. Okay, so here's the kind of thing and the kind of naming convention that it should have. So here, for instance, static variables are supposed to begin with a S underscore. Whatever the convention is, or global variables are supposed to begin with a G underscore, and enumerators are supposed to be all uppercase with underscores between words. Whatever the coding convention is for your project or for your personal taste or your organization, you can configure that, again, using the layered settings scheme. And if we just look at the ability to edit one of these, because naming things, there's a lot of little options, right? Is it the name of a struct? Is it the name of a class? Is it the name of an enum or a union or an interface or a type def or a type alias or a concept? Does it have qualifiers like, is it got a static or a const or a volatile or a const expert qualifier on it? Some organizations I've worked at had very elaborate coding standards for all these little subtle variations on the names and how things were supposed to be. Having ReSharper, especially if you're new to an organization and those naming conventions don't follow your own personal taste or intuition, and then in a code review you're always getting dinged because somebody's saying, hey, you didn't name your variables the way we like to name them. So you can configure all those little settings in ReSharper's options, and then let ReSharper tell you when you missed one. And you can get to it before you get to the code review. And then, trust me, if you have that level of scrutiny on your code within your team's going to be very appreciative of the fact that you took the time to get everything in the right style before they looked at it. Because then they're not distracted by style errors. They can look at your algorithms, maybe runtime complexity, or what have you, structure of the code, classes, how they interact, whatnot. They can get to the important things instead of getting hung up on all the little nitpicky stuff that can come up in a code review. So it's very handy in ReSharper to be able to configure all those settings to be just the way they have to be to meet your organization's style guide, essentially. And with my legacy code base, that was extremely useful in being able to say, well, I just picked, this is the style I'm going to pick. And I know there's a lot of identifiers that are floating around that don't match. And I started first with file names, and then I went to function names, and then I went to function arguments, and then I went to local variables. But I can run that inconsistent naming check in ReSharper on the entire solution, and I can find everything. And just, over the past week or so, I just happened to have fixed like thousands of minor deviations. And you might say, like, well, what's the point of doing all that? And the answer is because I need to make this code base friendly to other contributors. And the more consistent the code base is, the easier it is for other people to get a handle on what's there and make contributions that are consistent instead of letting things kind of wander off. So, again, the things I use all the time, every single day, are the navigation stuff. Was one thing I didn't show yet with respect to navigation. If we go over here, in this drivers.h, I have a pure virtual interface. And this code base doesn't have very many classes. It has a few, and it only has like really one polymorphic, runtime polymorphic class, and that's this driver class. The thing that comes up often when familiarizing yourself with a class hierarchy is you want to say, oops, I'm not a fan of that pop-up. Let's get my cursor here. And I will Alt context menu, so it's not getting distracted by my mouse movement. We can navigate to derived symbols. I don't normally do this through the context menu. I normally just press Alt-End. But if we go to derived symbols, it's saying these are the classes derived from driver. There's Win32 base driver, this disk driver, and this GDI driver. If I go over here, you see the Win32 base driver is in bold. That means it's an immediate derived class immediately. So its base is driver. If we press return on that, you can see, yep, sure enough. I had to wait for the IntelliSense to catch up there. Win32 base driver derives immediately from driver. And then if I go over here and Alt-End, we see that disk driver and GDI driver immediately derive from Win32 base. And if we go over to disk driver, if I say, if I do the, let's get it, let IntelliSense catch up here. Okay, if I say instead of Alt-End, there's no derived classes were found. But if I say Alt-Home, it took me to the base class, the immediate base class. There's only one base class, so it just took me there instead of showing me a pop-up. And then if I go Alt-Home on Win32 driver, Win32 base driver takes me to driver. So Alt-Home and Alt-End, or via the context menu, show derived or show base class, let you navigate a complex class hierarchy. If you have, GUI framework with many different controls deriving around, or some kind of other complex runtime polymorphic class hierarchy, maybe you're doing COM objects and they all implement multiple interfaces, and so in which case the derivation hierarchy is a little more complicated. Being able to navigate the class hierarchy quickly like that is extremely useful if your code has runtime polymorphism in it. That was the only other navigation tip that I wanted to mention, but navigating, doing that all the time. Most of the time I'm Control-T, my universal symbol finder, either to get to a file or get to a symbol. Refactoring, renaming, I do that a lot. Extract function, extract variable, less often inline variable or inline function. Change signature happens pretty frequently as well. change signature tends to be more on uh, new on existing code that I'm extending, as opposed to new code that I'm writing. New code is you end up with duplication starting to appear, and then you do extract function to squish out the duplication. The unit test accelerator to be able to navigate my tests, run a single individual test case straight from the IDE without having to fiddle with gtest command line arguments, or setting my current startup executable in Visual Studio Solution Explorer. Being able to debug tests, something I do all the time. Inspections, there's lots of little things that will come up either when this little hammer icon appears in the gutter, or that little light bulb icon appears. There's just a lot of little things that I do quite often. Probably it's mucking around with control flow statements, switching an if statement so that instead of it being a big nested conditional, you can switch that to using a series of guard clauses that return early so that the nesting level is decreased. Things like that. And changing the severity of inspections to suit my taste, because kind of out of the box it'll have some set of default things that it'll suggest to you. Maybe you disagree with those defaults, or maybe there's some things you wanted on by default and they're set to ignore, or there's things that it's chattering at you about that you don't want to. Maybe you don't want to deal with it now, or maybe you don't want to deal with it ever. So you can configure the severity to be lower, maybe just a warning instead of an error, or maybe no suggestion at all, just be silent. And layering all that through their what they call their layered options mechanism, so that you can customize things, but also share stuff between the team. It's all very useful. So I am a very satisfied customer. I use it at work, and I use it in my personal projects. And I couldn't imagine programming in C++ without it. It just makes me so much more productive. And it's not to say that I haven't tried other add-ons from other companies. I just found, as obviously my Refactor test suite reports, I just found ReSharper to be the best one. If something comes along that's better, I will gladly switch to that. Now, I use Visual Studio because it supports ReSharper, but if I were developing in a Linux environment where I wasn't going to be using Windows at all, I would just be using CLion, which is their IntelliJ-based C and C++ IDE. It has many of the same features as ReSharper. It's not, not necessarily one-to-one. They are in the process of unifying the source code analyzing engine between ReSharper and CLion. I think that was supposed to be completed first quarter of 2025, if it's not completed already. I haven't, since I'm not using CLion, I haven't checked. But there are a few little things, few little refactorings that CLion had that weren't available in ReSharper. I expect that when they get their code analysis and parsing engine unified between the two, I would expect to see more parity of features. It's just a few little things. It's not a significant difference between the two. But as I say, if you're over in Linux land, go ahead and try CLion. Again, you can get that for a 30-day free trial. Like most IDEs, it's going to be a little bit slow going at first because you're in a new environment. You got to learn new keystrokes and all that sort of stuff. As I described in story time, I've already gone through that several phases already. And even with Visual Studio, they sometimes change key bindings or the default key binding associated with a ReSharper functionality is not to my liking, so I'll go and customize it. But pretty much I use the standard set of key bindings, and it's been pretty stable for me. But that is a lot of yakking, but it is such a great tool that I felt it was important to spend some time on it. There's obviously more features in ReSharper that I haven't discussed. I didn't go into all the details of all the different little checks that they have, but you can read about that in the online documentation. You don't need me to explain that to you. I went over the ones that I use on a day-to-day basis, and I just find it makes me so much more productive as a developer that it just feels like it's like if I have to go back and write C code, I really miss the things that I get from C++. And it feels like you're just, putting me in leg irons if I have to go program in C and I can't use C++. It would be a similar thing if you said, well, you have to write C++, but you can't use any IDE. You have to just use plain VI. It would just feel really painful. So, strong recommend from me on all fronts. As a user, as a person that's reported many bugs and gotten many bugs fixed, been very, very happy with the product and the company. So, there you go. Get at it.